Hi everyone. Thank you for joining this presentation on video extenders and DisplayPort cables. Thank you, Priya, for the introduction. So, as Priya mentioned, I work as field application engineer with Vitex, and I'll be giving this presentation on DisplayPort cables. This is the first presentation in a series of presentations in which I'll explain what are these cables and how to select the best one for your particular application. So diving right into this presentation about DisplayPort cables, let me explain you what are the different cables which are there for the different audiovisual applications. So these are listed as follows. So currently and in the past, we have had different cables which are used for audiovisual applications. These are DisplayPort, HDMI, USB 3.0 and above, VGA, DVI, and RCA. These are some of the popular ones which have been used mostly by day-to-day customers and industrial customers for their applications. You might be wondering that why haven't I included USB 2.0 or any USB below 3.0? The reason being the models below USB 3.0 were primarily used for data transfer and never used for video streaming and audio applications. They have been incorporated in USB 3.0 and above. Okay, so after that, I'll explain some important parameters which are necessary for choosing DisplayPort cables when you're trying to see if this particular cable will be compatible for your application. So the main parameters are the type of connector. There are different types of connectors which are available for DisplayPort, and you might want to see which exact connector are you looking for. The type of material which is used for the cable. There are three main materials that are copper, fiber, and hybrid. The third important parameter is the resolution or the refresh rate, which is specific to your graphics card and the type of display you are using. The fourth is the length, as to how long of a cable do you need for your specific application. The fifth one is AOC or detachable. I'll explain about this more when in the upcoming slides and try to demonstrate as to what exactly is AOC and what is detachable and how are they used for different applications. And the last part is multi-stream transport, also known as daisy chaining, which basically means you can use multiple displays for a single source. So don't worry, I'll explain all of these parameters in detail in my upcoming slides. So you might be wondering what exactly is DisplayPort cable and why should you choose DisplayPort cables when you have so many other options like HDMI, VGA, DVI. So let's get into this. So DisplayPort interface, one moment, I just minimize this. DisplayPort cable was developed by a consortium of PC and chip manufacturers, and it was standardized by Video Electronic Standards Association, also known as VESA. And this cable was developed in order to succeed VGA and DVI. Now we all know that VGA and DVI are pretty bulky connectors, and it gets tedious in order to connect them. It was also important that most of the devices which are coming in are pretty slim, so they could not accommodate the connector type required to connect VGA and DVI cables. So in order to do that, DisplayPort cable was born, and it has a pretty slim connector type, so it can be used with most of the latest devices. In comparison to HDMI, DisplayPort cables support higher bandwidth and refresh rates. So it's an ideal cable or a connection for applications requiring very high refresh rates and resolutions, especially gaming, in which you need to have very high refresh rates. One of the biggest advantage of DisplayPort cable is that it can support multi-stream transport. As I explained earlier, multi-stream transport is where you have multiple monitors for a single source. This is especially important in the medical field and in surveillance applications and gaming. So typically it's basically, it's used to connect between a video source and a display device such as a monitor. As depicted in the image, you have a laptop or your computer, and then you can directly plug and play the cable into one port of the source, that is a laptop, and the other end to the display monitor. Typically, a DisplayPort cable looks like this. So there are two types of connectors. One is called the DisplayPort and the other is called the Mini DisplayPort. Both of them are certified by VESA, and Mini DisplayPort was specifically developed by Apple to be used for their laptops, which was later replaced by Thunderbolt. But that's for another discussion. So as you can see, DisplayPort is a wider adapter and the Mini DisplayPort is a shorter adapter. Both of them have 20 pins, which are used for different electrical connections. So moving on to the next parameter, which is material of the wire used. So as I mentioned earlier, there are three types of materials. First one being copper. So copper is traditionally used in most of the cables since the olden days to carry on the electrical signals. So since the mode of communication is electrical signals, it typically can go up to shorter distances such as 15 meters. Also, since the electrical signals are being used, they are not immune to other electromagnetic interferences which are happening around. So if using these cables, you have to be very certain that your cables or your system is not being affected by any other electromagnetic interference in the region. Otherwise, it can completely disrupt your system. Since copper cables are used, these cables are pretty expensive compared to other materials used for wires. Also, they do not support very high data rates. It can go up to 5 to 10 Gbps bandwidth, but not more than that. The next material is fiber. As we all know, fiber revolutionized the sending of data across different distances and for different applications. So fiber uses light as its signal for data transmission. As light can propagate up to thousands of distances, in this application, they can be used for very long distances, such as up to 100 meters. Also, since the light is traveling through fiber, which is typically plastic or glass, it's made up of a dielectric material and hence it's immune to electromagnetic interference. So it can be used anywhere without worrying about what are your surroundings. Compared to copper cables, these are more expensive. As you can see, the price is almost twice when compared to those copper cables. And since you're using light for transmission, it can support higher data rates, up to 20 Gbps and even more for these specific cables. The third type of material is hybrid. So hybrid contains both fiber and copper inside those cables. Fiber is typically used for transmission and copper for power. Since it's a combination of both of them, these hybrid cables are the most expensive compared to other two materials used for these cables. The next important parameter is resolution refresh rate being supported. So there are two main versions of DisplayPort which are currently in the market, although the standards are developed for higher modules, but they are still not in the market. So the ones currently are DisplayPort 1.2 and DisplayPort 1.4. So how do you decide on what kind of resolution or refresh rate do you need for your cable to support for your application? So it comes down to the fact that how much resolution and refresh rate is supported by your graphics card. So you need to look up your graphics card properties and the resolution supported by the display device, that is your monitor. Based on that, you can decide what resolution do you need for the cable to support. So in this table, I have summarized what are the performance characterizations of DisplayPort 1.2 and DisplayPort 1.4. So as you can see, DisplayPort 1.2 can support a resolution up to 4K at 60 Hz refresh rate, while the DisplayPort 1.4 can go up to 4K at 120 Hz. So that's a big jump, like twice of a jump compared to the DisplayPort 1.2. DisplayPort 1.4 can also support 8K resolutions at 30 Hz refresh rate. So 8K is twice the resolution of 4K, and basically it means that you can accommodate or transfer more pixels in order to display your data. Coming to the point of digital stream compression, DisplayPort 1.2 does not support DSC, while 1.4 can support DSC. Basically, it means you can compress your data to be sent at the same resolution at a higher refresh rate. Now, the bandwidth supported by DisplayPort 1.2 is 21.6 Gbps. Since there are 4 lanes, so it's limited to data. The per lane data rate is up to 5.4 Gbps for 1.2, and for DisplayPort 1.4, the total bandwidth is 32.4 Gbps, and the per lane data rate is limited to 8.1 Gbps. Coming to the next parameter, we need to decide how long of a length do we need the cable to be in order to support our application without any glitches. So as you can see, how you decide on the length is how far the source and display are from each other. If, let's say, you want to support your source, that is your laptop, and the monitor in the same room, you're typically looking at smaller lengths like 1 meter or 2 meters or 5 meters. But in case when you have source in one room and you want the display to be in a room farther from your source, then you're looking at longer lengths. Typically, these lengths are measured in feet or meter, and the typical increments are 1 meter, 2 meter, 5 meter, and goes on up to 100 meters. Some vendors also provide customized lengths in case like 37 meters or 63 meters or any particular length that you need. The next parameter is the type of cable end, whether it's AOC, that is active optical cable, or it's a detachable type. So the active optical cable is used to connect the source directly to the display. Basically, it's a plug and play type device. You just insert one end of the cable into your source and the other end into your display. The next part is it draws power directly from the connector ends in case of hybrid cables. So as I mentioned earlier, hybrid cables contain copper cables inside of them along with the fiber. So the moment you plug this end of the cable into the respective source and this in the display, they don't need to get power from any other source. They can directly consume the power from the connector ends. Basically, they have a pin to consume power from this end on both sides. Other type of cable end is detachable, and the primary use of this type of cable is to connect via a conduit running through the wall. So this is more applicable to applications in which you have a source in one room and your display in a very far off room, typically like a medical application or surveillance application, in which you want the cable to be running through the wall, and then you can just connect to the port in the wall and to your source or the display. So these type of cables can either draw power through additional USB attached at the connector ends or directly from the connector ends. So as you can see from the image, these are the spools or the cable which contains a cable which will run through the wall. And then these are typically the extenders which will directly be connected to the port in the wall and either your source or your display device. You can also see a small USB cable attached to the end, which is typically used to consume power. The next important parameter is multi-stream transport, which is also known as daisy chaining. So multi-stream transport allows you to connect a single source to multiple display devices. So as per VESA standard, the number of devices are limited up to 4. And this kind of daisy chaining is typically used for gaming, surveillance, weather monitoring, and medical imaging. Both DisplayPort 1.2 and DisplayPort 1.4 cables can support multi-stream transport as standardized by VESA. As you can see, this single laptop is connected to 4 different sources using DisplayPort. It's a DisplayPort hub, which can basically connect in one source to 4 different monitors. So there are different DisplayPort solutions offered by Vitex, and they are as follows. So we have DisplayPort 1.2 AOC and DisplayPort 1.4 AOC, and our DisplayPort cables adhere to all the standards which are specified by VESA. So our cables support the resolution and refresh rates to be supported as per the standard. So our cables support 4K at 60 Hz for 1.2, and for 1.4, our cables support 4K at 120 Hz and 8K at 30 Hz. As per the standard, 1.2 should not support DSC, and our cables accordingly do not support DSC, while 1.4 supports 8K resolution at a higher refresh rate of 60 Hz. Our cables adhere to the per lane data rate as well as the total bandwidth specifications also. So our cables support 5.4 Gbps for 1.2 and 8.1 Gbps for 1.4. For 1.2, our cables support a length of 30 meters with plastic optical fiber and up to 100 meters with glass optical fiber. Also, for 1.4, the lengths are supported up to 100 meters. The cables which we provide are made up of a material called plenum, which is a hybrid type, and basically it means it can be used at any of the place through the racks or overhead or along the conduits. This is the highest rated type, and this basically guarantees that the cables won't catch fire or do not pose any hazardous situation. Vitex also offers the detachable type cables, which are the pure fiber DisplayPort 1.2 extenders. So they can support the highest bandwidth of 21.6 Gbps as standardized by VESA. The resolution they support is 8K with 4K with the use of 4:2:0 compression ratio. They can also be used for 5K without compression and 4K at 60 Hz with 24-bit without compression. They can support lengths up to 1,000 feet because you need to be using them to be running through the conduits. So naturally, they can provide a higher range. And as I mentioned, the connector type is detachable, which basically means you connect one end of the extender to the one in the wall. So this connector will be sitting in the wall, and you connect your extender from this port to your source or to your display. So that's it for my presentation on DisplayPort. What are the cables and how do you choose which kind of DisplayPort cable is required for your application? Do you have any questions about my presentation?
Shantanu, there is a question in the Q&A box. I don't know, are you able to see the Q&A box?
Yes. Yeah. So the question is, how many monitors can I connect using DisplayPort cable? So you can either use one monitor, 2 monitors, 3 monitors, or 4 monitors. The limitation of 4 monitors is set by VESA. So DisplayPort cables should be able to support 4 monitors. Now, if you're trying to use more monitors, there's one thing that they won't be supporting all the monitors at the same resolution and frame rate. So let's say if you are using 4 cables for 4 monitors and then you want to use them for 4K resolution, that might not be possible because for all the 4 computers, the resolution would be limited to 1080p. Okay, I hope I explained it properly. Any other questions?
Okay, thanks, Shantanu.
Yep.
It was a very useful presentation, and thanks everyone for joining. If you have any questions or suggestions, do email us, info@vitextech.com. Like I said, we'll have the recording of this webinar up on our website later this week, and I'll send you an email also about it. So once again, thanks everyone for your participation, and have a wonderful rest of the week. Thank you.
Thank you.